All right, today we're going to talk about the slope of parallel and perpendicular lines. So let's talk about what are parallel lines. Parallel lines have the same slope and their lines will never cross or never intersect. Okay, so first thing we need to do, these two lines look like they're parallel. They don't show crossing on a graph, but we're going to verify by checking their slopes. So I'm going to find the slope of line A. So picking 2 points, I always like the y-intercept and x-intercept if I can, but not always possible. But there's another nice little point right there. Remember, we're looking where it crosses the grid nicely. All right, so I'm going to count my rise, which is down 3, and then I'm running 2. So I have a negative 3/2 slope here. Okay, and then I'm going to do the same thing on line B, pick 2 lines that, or 2 points that are good points to count for, and then I'm going to count my rise and my run. So I'm going down 3, get that out. So these lines are parallel. And that symbol right there oftentimes is denoted for parallel, or 2 straight up and down. Okay, perpendicular lines now. Perpendicular lines have opposite reciprocal slopes. All this means is a reciprocal is that if I take the 2 fractions and multiply them together, they're going to equal 1. So an opposite reciprocal means that if I multiply the 2 reciprocals together, I'm going to get a -1. So here's an example, 2/3 and -3/2. So if I were to take 2/3 times -3/2, okay, well, you multiply across the numerators. So 2 times -3 is a -6. 3 times 2 is 6. Well, 6 divided by 6 is 1. So we get a -1 there. With this type of slope, it's going to cause them to cross at a right angle. And this is the symbol we would use for representing perpendicular. Okay, so looking at these 2 lines, we're pretty sure they're perpendicular, but let's verify because crossing lines are harder to tell. So I'm going to pick 2 points on my line, and since where the cross is a really nice one, so we're going to use that. So I'm going to count my rise, which is 1, 2, 3, 4, 1, 2. So it's 4/2, which does simplify to a +2. Okay, now I'm going to use this same point here. Let me change my color so we can see the difference. So I am going to use this point again here and this point for line B. So I'm going to count down 1 and right 2, and I get a -1/2. So are these opposite reciprocals? Now remember, any whole number can be written over 1. So yes, these are opposite reciprocals, so therefore these are perpendicular. So let's just look at some graphs and we're going to determine that. Later on we'll look at equations and how just looking at their slopes. All right, so I'm going to look at the green line first here, picking out my 2 points. Got 2 nice ones there. So the rise is 2 and the run is 1. So I've got 2/1 or just 2 there. Okay, looking at the blue line. See, I've got a point here and a point here. Again, my rise is 2 and my run is 1. So these have identical slopes, so they are parallel. Okay, we're going to go over here. Let's start with our blue line. Oops. Our blue line. So I'm going to pick 2 points on the line there. And it looks like my slope again is 2 and my run is 1. So my slope is 2. Then we're going to look at the red line and I'm going to pick this point and this point. And looking here, we go down 1 and right 2. So that's a -1/2. Are these opposite reciprocals? Basically, my fraction flipped, yes. Okay, I could put the 2 over 1 if we flipped it and made it negative. So these are perpendicular. Okay, so let's look at the next set of, these ones might look like they're parallel. But let's actually look at that and see if we can determine, are they actually parallel? So looking at the green line, finding our slope, our rise is 2, our run is 1, so we have a slope of 2. Then if we look at the blue line, I've got a point here and a point here. So my rise is 1, 2, 3, but my run is 1. So I have 3 over 1, or just 3. Well, 2 and 3 are not the same, are they? So this one is neither as well. It's always good when we're looking at a graph to verify your slope before you just determine that they're parallel or perpendicular. Because even though they don't cross on our here, they are eventually somewhere going to cross further on our graph. If we were to continue that graph, keep going, they would eventually cross somewhere. All right, so we're going to look at these, an equation, and determine, are the lines parallel, perpendicular, or neither? Okay, so looking at this first set here, I've got y is equal to 3x minus 4. So now I have to look at, what is the slope of the second line? It's not really easy to tell, so we're going to put it into slope-intercept form. So I'm going to add 6x to both sides, giving me 2y is equal to 6x plus 4. And then I have to divide everything by 2. So I get y is equal to, well, 6 divided by 2 is 3x. 4 divided by 2 is 2. So do we have the same slope? We're just looking at this number right here. And yes, so these would be parallel. Okay, looking at the second one, I've got y is equal to 1/4 x minus 4. Okay, my second equation's in point slope form. So where do I find the slope for that? Right here. Okay, 1/4 is that opposite reciprocals with negative 4. And yes, if we put a 1 underneath that negative 4, my fraction would be flipped. So these are perpendicular. So remember, parallel sign is this, perpendicular is this, and we do write the word neither if they're neither. All right, looking here, I've got 6x minus 3y equals 8. And y minus 4 equals 3x minus 3 times x minus 4. All right, so top one is in standard form. We need to rearrange that. We know our slope here is 3, so let's see if we get the same slope. So 6x minus 3y equals 8. So first thing I do is subtract 6x. And I get negative 3y equals negative 6x plus 8. And then I have to divide everything by a negative 3. And I get y is equal to, well, negative 6 divided by negative 3 is a positive 2x. And we can't simplify that, so I'm just going to leave it as negative 8/3. This would not be a fun one to graph. But we're only looking at slopes. So are my slopes the same? No. So these are neither. These are neither parallel nor perpendicular. They're what we call intersecting lines. So same slope, parallel, opposite reciprocals, perpendicular. Now let's talk about a kind of a special case. We've got y equals 3 and x equals 5. So what is the slope of the top line there when we have y equals a number? Remember, my slope here is 0. Okay, what about the second? And x equals? Well, the slope there Anytime we have an x equals is undefined. So what would my graph look like? Okay, I've got y equals 3, which would be this horizontal line right here. And then x equals 5 is my vertical line. So, are my lines parallel? No, they're crossing, right? So they at least intersect. But are they perpendicular? And that would be yes. If you have a y equals a number and an x equals number, or a slope of 0 and a slope of undefined, then yes, you have perpendicular lines. All right. That is all I have for this video. In the next one, we will actually talk about writing the equations for parallel and perpendicular lines.